Hey, it's still Duff. Welcome back to the channel. And yeah, I'm a little frustrated. I just got done with an interaction on Facebook in which I just found myself having to critique a meme that was posted by a Facebook friend of mine. This particular Facebook friend has posted, I can't even count the number of memes in which most of the information on the meme has been incorrect. It's been wrong. We're going to take a look at one. In fact, I'm going to say that he's my inspiration for starting this new series, Meme Myth Busting, breaking down creationist memes. Or I'll just pick out a meme and then let's just talk through what the misconception is in that meme. Well, you ready for it? Yeah, let's dive in. This is the meme I just saw and it just fired me up to do this. All right, here we go. 54 million years. Yes, 54 million year old in quotes, because of course we don't believe this was really 54 million years ago, but scientists say that this gecko is 54 million years old that is preserved in amber. Let's contrast and compare with the gecko that's alive today. All right, so we have Nautilus elegans, the green gecko found in amber, and then we have to the right, we've got Nautilus, I can't say that, I don't know how that's pronounced, elegans, the green gecko from today. And can you spot the difference? Right? The childhood game of two pictures, and can you find any differences? Obviously you can't. These are almost identical organisms and therefore members of the same species. But wait a second, 54 million years? Obviously evolution hasn't happened. This organism hasn't changed over 54 million years. Checkmate, evolutionist. Creationism is correct. Where is the evolution? Right? And then notice the byline at the bottom. Evolution is dishonest government propaganda. Do not be deceived. Unfortunately, it's the one that's taking in this meme and sharing this meme that is part of the deception. And that's what frustrates me so much. That is what's really frustrating, is that memes can be, they're powerful communicators, because the combination of visualization and sort of catchy bylines and quick messages, right, are easy to grasp. You can get the idea, like it's right in your face. Like, hey, there's no difference between these organisms. How could they not have changed over 54 million years ago? It's going to leave an impression upon you. So I'm frustrated because here this person is a professing Christian, and I'll just say that they're in a position of leadership in a church that is, I'd say, closely related to the denomination that I'm a member of, and therefore, in a way, kind of embarrassed, right? I was like, that's especially frustrating. It's one thing to just have Joe Schmo sharing something and they don't know what they're talking about, but it's somebody who is representing a point of view, right? They're representing a particular perspective on how they interpret scriptures. And they're so caught up in that they share anything and everything that they see without having any idea how accurate it is. It's a bad look that really disturbs me. I don't want these, breaking down creationist memes to be long videos. These are meant to be short things. So let's just get at what's wrong with this particular thing. All right, the 54 million years, that is the estimated age of this piece of amber. And so that is just information extracted from the original article reporting this. But then we've got the scientific name, right? We've got a scientific name of this organism, Nautilus elegans. And so what's being shown to you is that these two have been called the same name. Now you would be forgiven if you got the impression from this. All right, this is the power of the meme. You get the impression that, oh, these have been given the same scientific name. Now, who names organisms? By the way, I've named an organism. All right, I've named several different species. And there's a process you go through to do that. Right, and you put it into the literature and so forth. There's an official there's an official way of making a scientific name for organisms. Right, Nautilus elegans is the scientific name of the green gecko. Right, that's been published by somebody probably fairly long ago. and that name established. So you might think that this other thing from amber, whoever described this piece of amber, whatever scientist was looking at this amber and then described this organism that's inside of it, also identified this particular organism as being this same kind of gecko. But in fact, that's not the case at all. And I'm going to show you the paper. It's been given a completely different name in a different genus, right? So a different genus and a different species. And so not at all the same, because as the authors say, this organism has unique traits. They're not found in any living gecko at all. Now, to your unaided eye, all right, to the average person, and I'm the average person in this case, I don't know my geckos, I don't know my exact gecko taxonomy and all the individual characters and what the diversity of features are in geckos. All right. So to me, yes, I kind of look at that and go like, yeah, there's a whole lot of similarities between those two organisms. A lot of similarities between a lot of organisms on Earth that actually aren't really closely related to one another, right? Um, and so anyone who looks at this, well, okay, I'll show you the paper, and then you can see some of the amazing detail in this organism trapped in amber. And by the way, this thing found in amber is less than an inch long, whereas the gecko that's being shown in this other picture is something that's more like 10 or 11 inches. So the scale is not exactly right here. So for that comparison either. Okay, there's a couple other inaccuracies here. All right, so that for one, that's the thing that really I think gets me the most, is it makes it look like scientists have named these two things the same thing, when in fact, no scientist has named the gecko in the amber as the same species. They have recognized differences and made an argument about why it shouldn't have the same name. And so whoever made this meme is just outright lying. Okay? They're lying. Maybe they thought it looked similar, and so they found out, oh, this other thing's called a green gecko, so they named it a green gecko. If they did that without looking at the literature, yeah, all right, that's not as bad, but it is their point of view. I don't know who actually made this meme. That's the other thing about memes. Who's the author? We often don't know who produced the particular meme. Do they have any expertise in this area? I suspect not. And here's why I suspect not. Look at the scientific name, right? you know, if you were in my class, I would be taking points off if you wrote the name that way. What's wrong with it? It should be a capital N, right? And then it should be italicized or underlined if you really want to be proper in terms of the proper etiquette for writing out a scientific name, right? And because that's a Latinized name there, right? So that should have a capital N, right? So whoever made this meme wasn't aware of those basic rules, all right, for how you write out scientific names. Therefore, I don't think they're actually any kind of expert in geckos. I don't think they have any scientific expertise in terms of the taxonomy of geckos at all. They simply did what you might be doing, which is looking at two pictures, not in really close-up detail, not knowing anything about the morphological characters and what varies in geckos and what doesn't, and just sort of gross appearance going like, yeah, they look kind of similar. Kind of like flying squirrels and sugar gliders. You know, some people get those kind of mixed up. They think there must be closely related organisms, like maybe they're just two different variations on a theme. But sugar gliders are marsupials, and flying squirrels, which I have in my attic, are a type of rodent in this area. So very, very different types of organisms. But on the surface, to the person who doesn't know they're mammals, I just think they look kind of the same. Right? So in fact, these two organisms are quite different when you get down to minute details and start really looking at them. The other thing here is evolution is a dishonest government propaganda. Government propaganda? I don't know, was Darwin paid by the government to come up with the ideas for evolutionary theory and so forth? Yeah, sure, there are scientists who have grants, that are paid by tax dollars. They're studying organisms, and maybe this particular scientist that is identifying this organism in the amber actually has federal tax dollars, but maybe not. And there's lots of scientists now, that people who aren't working for the government. This isn't a government conspiracy. Um, so don't be deceived. You know, the thing is, if you are looking at this meme and it's being shared, I've seen this meme dozens of times, right, on different uh, boards. In fact, this was actually showed up on a group, a Facebook group called Biblical Creation, right? So purporting to be biblical creationists, here we are, we're Christians who are representing the Christian faith, and here is our defense of biblical creation. Our defense is to not know what we're talking about and to literally be lying about what the literature says about these different things, about these things, right? And cast aspersions on those who are studying and their motivations, right? So who's being deceived here? This is not the best Christian witness to be promoting your ideas. Shouldn't you be, if you are right in your beliefs, shouldn't you be able to use truths rather than lies to make your point? All right, so real quick, let's go to the paper, because I think it's kind of cool to look at the details of this particular. It's a really cool fossil, so let's learn something from this. So I went and looked up the original article rather than just the catchy, for the public blurb about this, which did not say that it was the same species, and even did note that there was differences and that this particular gecko found in the amber was unlike any modern living gecko. I mean, it has similarities, obviously, right? And it is maybe a member of a larger family of geckos, but it's not any particular species of gecko that's alive today. So here's our paper, The Early Eocene Gecko from Baltic Amber and Its Implications for the Evolution of Gecko Adhesion. Geckos are famous for their being able to, some of them, because of their toe pads, being able to walk up like glass, surfaces, vertical angles. And so they have amazing adhesive properties that have been studied. In fact, where I work, there is a colleague of mine who studies gecko toe pads. And I've looked at those toe pads, and I've actually served on a number of committees of students of this particular faculty member. And so I've gotten to see some of the research that they're doing on gecko toe pads, along with some other engineering departments. Right, so really cool research. We call it biomimicry, right? You're studying natural things to understand, like, how do they adhere to a surface, and then can we mimic that adherence, with other products that we might make. This is in the Journal of Zoology, London, from the Zoological Society of London from 2005. A new genus and species of gecko. So there it is, right there in the abstract. This is not the same species as the green lizard or the green gecko, right? So a new genus and species of gecko from the lower Eocene, northwestern Russia, is described from the superbly preserved specimen in Baltic amber. It's the oldest geckonid lizard to be represented by more than fragmentary skeletal remains, right? I mean, it is an awesome fossil because it shows incredible detail of what was the soft tissue portions of the particular organism, rather than just having bones, which is pretty tough to do reconstructions with in various lizards. The digits of the specimen are mostly intact and reveal a unique combination of characters not seen in any living form. There you go, again, right there in the abstract. This thing has unique combination of characters not seen in any living form. No, I'm not going to read this. I'm not going to read this paper for you. It's lots and lots of morphological jargon. There's our fossil, the full thing. Let's get down to the pictures. Whoa, check out these close-ups of the skin. Right, the palmar view of the right manus of holotype. By the way, holotype means is the original specimen for which you have named an organism. Right, when I've named a couple different plants, and when I did so, I had to name a particular specimen. So I've collected and observed lots of individuals of that particular thing that I thought was a species. I did a bunch of molecular characterization, said yes, all these are very similar to one another genetically and also morphologically, but they're dissimilar to all the other things that there's this other species. So people previously had lumped these two things together. I said, no, really, these are two different species. And so I identified the variable characteristics and the range of their characters. And then I said, okay, I got to pick out one member that I've collected of this plant. And I wanted to represent sort of like the typical version of the species. And then I set that aside. I make what's called a herbarium specimen, right? Flatten it in a book. I didn't really flatten it in a book, but as a kid, remember, you made flattened leaves and dried them and stuff, right? But I did flatten them, all right, in a plant press. And then I took that and put it on a special piece of paper, cotton paper, and then there's a type of label you put it on that, and you give it to a herbarium, right? In this case, the herbarium is in Tennessee, University of Tennessee. So in that herbarium, there is a specimen there that represents the plant that is named Isoetes caroliniensis, right? The one of the plants that I've named. And so that plant, then that particular specimen, then kind of is the retainer for that particular name. So this particular specimen, of course, there's only one specimen. This is the only one they have, the only one we know about, and it's completely unique, found in a unique layer of rock in this particular amber. And so they're saying, like, yeah, this is the holotype, the original version, and everything else has to be compared to it. So let's say somebody else finds another piece of amber in a similar location, and there's another gecko in it. They can look at that gecko, and what they need to do is they need to compare it to this particular gecko, and they need to figure out, is it similar? Is it similar enough that we think it's probably the same species? And then if they find 20 other ones, what they might find out is that, like, there's 6 or 7 samples that have a whole set of variations or characteristics that are different than the rest of them. And they could end up splitting those two groups of individuals into 2 piles and saying, like, hey, you know what? These 7 and these 13 samples we have, they're different based on a whole bunch of different characteristics that are consistent within those 2 different groups. We're going to name those a different species. Well, the one that's most similar to the holotype, whichever one the holotype has, like this specimen, the ones that are similar to it are going to keep that same name that it was given. And then whoever's studying them and says, no, these 7 are different. That's essentially what I did. I said, like, hey, these samples really are different. And so therefore, I'm going to name them, I'm going to separate them, and I'm going to name them something else. Right, so I might give it the same genus name because I think they're related, and then I'll give it a different specific epithet, which is the second part of the name, right? Homo sapiens, or Taraxacum officinale, which is the dandelion. By the way, love the little, the bumpy skin here. They have damage to the digits, but it is the digits that are unique. Apparently, again, I don't know my gecko, morphology, but apparently these digits are quite different than any of the digits of modern day geckos. That's it. It's a fairly short paper, but what it is it's describing this. Oh, so here we go. Here's the family they're going to place it in. So that is a known family of geckos. And then within that family, they're calling it, I'm not even going to try to pronounce that, but this would be the scientific name right here, right? So you got your, you got a capitalized genus, because the genus is always supposed to be capitalized. And then they're noting that it is a genus that is species nova, which is brand new species. And the etymology would be like, why did we name it this? How did we give it this name, right? So here's this Latin name, and it comes from, the fact that it comes from Russia, meaning amber, and so forth, right? And then after that, you would have, here's the holotype information, and this is where it is registered. This is where it's been deposited. So if anyone else needs to study it, needs to understand this or compare it to their sample, that's where they would go and they could take a look at it. And then you have got your type location information, right? The holotype, the type specimen. This describes the location where it was found. And then you have your diagnosis, right? And your diagnosis is going to be, hey, here's the description. Here's why it's different than anything else. And so, here are the characteristics that it has. Some of those are similar characteristics to other organisms, But some of these are also unique, and the reason the unique characters are the ones that give us the right to give it a different name and think it's a different species. In fact, they don't think it's just a different species of a genus. They think it is a different genus. In other words, it's different enough that it's not just, yeah, a little different species. It's a different genus. And that again goes back to the meme, right? 54 million years. Oh, these two things are the same. Evolution hasn't happened. But in fact, these organisms are fairly distinct. And so having two different genera in a family and being 54 million years old, that's not really a shock. Right? That's not a shocking thing. Right? And it's not a shocking thing to have two organisms look that similar over that much time. They have accumulated differences. Some organisms live in very similar environments over long periods of time, and therefore natural selection is going to select for them to maintain their morphological appearance because those characteristics work well in that particular environment. And so that's not shocking to find that some species, some genera aren't changing that much in their external appearance. But as I said before, these actually have changed a fair amount, even if you just like your gross visual quick inspection suggests that they haven't. So in the diagnosis, that's where they're talking about all these different characters, and they're showing these pictures, and so you see lots and lots of terms about in each individual characteristic of this thing. And then they have a discussion about it. And most of their discussion is focused on the toe pads, because that's what people are interested in, because that's what geckos are known for. And what's interesting about the sample is they do have some of the features of toe pads, the setae they're called, the little tiny little flaps of tissue and hairs that allow them to make these connections and allow them to stick to walls. And so what they learned from this fossil is that, yes, even 54 million years ago, there was already these types of features that geckos had. All right, so we're back to the beam. All right, I think that's it. I think we've broken down this particular Cretaceous meme. Is there anything here that destroys evolution? Not really. This is not anything that an evolutionary biologist would be shocked by. They wouldn't be surprised by this at all. Now, if you frame it as these are the exact same species and they are exactly the same in all their characteristics, well, that would take a little bit more explaining, all right, over 54 million years. I would expect some differences to have arisen in 54 million years. But where is the evolution? The evolution is right there if you just look close enough. All right, so do not be deceived by this particular meme. And those of you out there that are sharing it, do better at trying to understand the meme and be careful before you share a meme. Again, we don't know who the author was of this meme. We don't know well, I know what their intent was. Well, do I? Is their intent, do they really believe what they're saying here? Because it seems like they had to be deceptive in order to communicate their message. And so again, that's my concern, is the appearance of intentional deception. And then my friend on Facebook, I don't think he's trying to be intentionally deceptive, right? He's not like, oh yeah, I know this is like, probably not really accurate, but this is what I believe to be true in general, right? The creationist paradigm is correct, and so it's still good for me to share this because it's going to help people turn them away from falsehood. I think he has good intentions, but he doesn't have discernment, right? That's really what I'm calling for. I'm calling for discernment. I'm calling for not just indiscriminate, oh, this fits my worldview, and therefore I believe the author and I believe the information is correct, and I'm just going to share it with all my friends. A little fact checking might be nice. And I guess I'll just continue this complaint. The other thing that I'm bothered by is, right, I do know something about this. I'm not an expert on geckos, but I do know how to do a little research. I do know how to look up information. I do know when I see something that I suspect has problems, like, hey, they didn't capitalize the genus name, that right away tells me these are non-experts doing this type of stuff. That sends up a little signal in my mind that something might be wrong here, right? And so I am an expert enough to see that, yes, I'm being deceived. I am. Somebody is trying to deceive me with this particular meme. And so those who I have talked to about this particular meme, and I've shared my concern, like, here's the misinformation. I don't expect them to, like, okay, my worldview is wrong, right? They've been deceived by this little piece of data, right? And so I'm not asking them to completely abandon their beliefs, but I would at least appreciate somebody saying, "Oh, yeah, I really don't want to. I don't want to deceive others, right? I don't want to share misinformation." Right? I'll go find better information, correct information, because I believe it's out there, because I believe my position is correct. Um, don't use lies to try to preach your truth, right? And when it's pointed out to you that there's a problem and that this is obviously wrong, like the naming of these two things as being the same species is a lie, right? That's You could follow up on what I'm saying here and go look it up for yourself and find out. But no, what happens is people double down and just, oh, well, what about this example? No admission that what I shared and what I sent to my 200 friends and told them, like, wow, look at this. This is great information. No attempt to say, oh, I might have been wrong about that. You might not want to repeat that, because somebody like me who you talk to and tell that is going to say, no, actually, they don't know what they're talking about, right? And you don't know what you're talking about. And he doesn't know what he's talking about. And again, I don't blame him directly for not knowing. He's been deceived. And that's what memes do, right? They create an incredible amount of deception. And so once you've seen, and like I said before, this person has shared a lot of memes, right? And almost all of them I can look at and go, like, that's wrong. That's an incorrect fact. That is improper comparisons. I mean, they're chock full of misinformation. And so that's massive an accumulation of information that's being fed into this person's mind all the time, and he's sharing that with lots and lots of people. Okay, that's it for meme myth busting for today. Um, yeah, I think this will be a fun little series. I see I'm already at 30 minutes, which is about 20 minutes beyond what I'd hoped I would be. So I, I'm, I'm desperately trying to rein myself in. And so maybe next time I'm going to try to give myself a 10-minute timeline in order to do the meme myth busting things. All right. Hey, I really appreciate you hanging out, listening to me. We'll talk to you later. Bye bye.